In our previous lesson, we looked at several examples of adding and subtracting decimal numbers. In this lesson, we want to continue to focus on decimal numbers, but this time I want to look at the operations of multiplication and division. As we do so, we want to make sure we understand the steps involved in performing these operations. It turns out that much of what we've learned in multiplying and dividing whole numbers is going to come into play in these problems as well. So please be sure you have those skills mastered before moving forward to this lesson. Let's get started with a pretty basic example. I want us to multiply the decimal number 3.2 times the whole number 7. Now, as with our previous work on multiplying, the first thing we want to do is write the problem vertically, not in a horizontal fashion, but with one number above the other. The key here is to not worry about lining up the decimal points. This is a huge difference between adding and subtracting decimal numbers versus multiplying and dividing decimal numbers. We do not have to line up those decimal points when we multiply. So we're just going to write the two numbers, one above the other, in a right justified sort of way, with the 2 just above the 7 in the example. Now, I want to actually ignore the decimal point that's in the 3.2. We can't forget about it completely. It will come into play by the end of the problem, but for now, we don't have to do anything with it when we're multiplying. Now, we just multiply as we did when we were multiplying whole numbers, working our way right to left. We know that 2 times 7 equals 14, so we write a 4 under the 7, and we carry a 1 above the 3. Next, we know that 3 times 7 equals 21, and then we need to add in that extra 1 that came from the carry, and 21 plus 1 gives us 22. So we write this 22 to the left of the 4 and the answer section of the problem, and at this point we have 224 in the answer section. Now, with that said, let's pause and think for just a moment. We started the problem by multiplying 3.2 by the number 7. That means our answer should be something around 21, because 3 times 7 is 21. But of course, we multiplied by 3.2, not just 3. So our answer is going to be slightly bigger than 21. But right now in the answer section of the problem, we have 224. That is way too big. So why is it the case that we have such a big answer at this point? Well, it's because we have one more step we need to perform in order to finish the problem. Remember, there's a decimal point that we said we could ignore at the beginning of the problem anyway. Well, now we need to bring that back into the answer. And here's how. I want you to answer this question for me. How many digits in the numbers in the original problem were to the right of the decimal point? Well, in the 3.2, we have exactly one number that's to the right of the decimal point, and that's the number 2. And in the 7, there are no numbers to the right of the decimal point, since we understand that the decimal point in 7 is just to the right of 7. So there's exactly one digit to the right of the decimal points in the original 2 numbers that we started with. And that means that we need to go back to our answer section and we need to place the decimal point in our final answer so that exactly one digit in the answer is to the right of the decimal point. That means our answer is not 224, rather it's 22.4. You see now that one digit, in this case the 4, is just to the right of that decimal point, and that's perfect. And notice that this answer, which is just a little more than 22, is in the right ballpark, because a few moments ago we said we wanted an answer that was just a little bit bigger than 21. Now, let's move to a slightly more complicated multiplication problem that involves decimal numbers. Here's what I want us to do. Let's multiply 4.71 times 5.2. Now, just like in the earlier example, I'm going to write my numbers vertically, and I'm going to push them so that they're right justified, if you will, so that the 1 in 4.71 is lined up just above the 2 in 5.2. And of course, we're going to line up all the other digits accordingly, but I just want to push the numbers basically both to the right, if you want to think of it that way. Now, I understand that the 1 in 4.71 is in the hundredths place, while the 2 in 5.2 is in the tenths place. It doesn't matter, though, that those two digits are lining up when we're multiplying. It would matter very much if we were adding or subtracting, but not when we're multiplying. We don't have to line up those decimal points when we're multiplying decimal numbers. Now, I can ignore those decimal points for now and just complete the multiplication process as if the two numbers were just whole numbers. Again, working my way right to left, I'm going to start with that 2, and I'm going to see how the multiplication goes. So here's what I do. 2 times the 1 is equal to 2, and so I'm going to write a 2 just below the 2 in 5.2. Next, the 2 times the 7 equals 14, so we write a 4 in the answer section just to the left of the 2 that we wrote a moment ago, and then we carry a 1 from the 14 above the 4 in 4.71. Good. Next, let's multiply that 2 by the next digit over, which is the 4, and 2 times 4 equals 8. But don't forget, we also carried a 1. 8 plus 1 equals 9. And so I'm now going to write a 9 to the left of the 4 in my answer section. So the only thing in the answer section at this point is the number 942. We might say it's 942. But for now, it doesn't have to include a decimal point, and I won't worry about the decimal point until the very end. Now, let's go to a second line in the answer section, and remember what we have to do when we go to that second line when we're multiplying? We write in a 0 in the rightmost position. It's that 0 that's reminding us that we're now multiplying by the second digit from the right, and that's the 5 now in the number 5.2. Now, once we have that 0 written in, we can start to multiply. And so I'm going to have 5 times the 1, which equals 5. So I'm going to write a 5 just to the left of the place holding 0. Next, I'm going to take that 5 and multiply it by the 7. I'm working my way right to left through those digits. 5 times 7 equals 35. And so I'm going to write a 5 from the 35 just to the left of the 5 that was already in the answer section. And now I need to carry a 3 because I had 35. That 3 gets carried above the 4 in 4.71. Next, I'm going to multiply that 5 times the 4. And when I do, I'm going to have 5 times 4 equals 20. And then I need to add in that 3, which was carried over. 20 plus 3 equals 23. And so I'm going to write 23 next to my 5. And that means I'm going to have then a second line in my answer section, which is 23550. Now, what do I do with these two numbers in my answer section? I need to now add them. And now I have to make sure that everything is lined up correctly, because when you add, the corresponding digits have to be lined up vertically. But thankfully, I've already done that. I've already lined those digits up correctly. And when I add them, going from right to left, I'm going to have 24492 as my answer, my final answer. Well, it's not exactly final, is it? Because I haven't put in my decimal point yet. And it's very important that we now insert that decimal point. The answer here can't be 24,492. That's way too big since we started with such small numbers in the first place. Okay? So if we're thinking correctly, our answer really ought to be closer to like 25, because the two numbers we started with were both about 5. 5 times 5 being 25. Now, how am I going to get the right answer if what I have in the answer section right now is 24,492? Well, I need to go back and do something with those decimal points that I ignored. Now, notice in the original problem that there were actually 3 digits that were to the right of the decimal points in the original numbers. There's a 7 and a 1 to the right of the decimal point in 4.71, and there's a 2 to the right of the decimal point in 5.2. So I need to go back to this answer section, 24492, and I need to insert that decimal point in the answer, exactly where we would make 3 digits of the answer appear to the right of the decimal point. And that means that the decimal point in this answer must be placed right between those two 4s, so that my answer is actually 24.492, or 24.492. Do you see how exactly 3 of the numbers in the answer are to the right of that decimal point? That's exactly what we needed to do to finish the problem. And that number is very close to 25. So we know that we're in the right neighborhood with that answer. Now, let's look at one last example of multiplication of decimal numbers before we move on to some division problems. I'd like to suggest that you try this one on your own to see how you do, and then we'll come back together and see if you got the right answer. Here's what we're going to do. I want you to multiply 4.02 times 0.65. Now, as before, let's start by writing the problem vertically. I'm going to push all the numbers over to the right. In this case, when I do that, the decimal points really will line up, but I don't care about that when I'm multiplying. I'm basically just going to push the two numbers to the right so that the 2 and the 5 line up. And now I'm going to ignore those decimal points for at least for now, and then I'm going to start my work. Remember though, you have to come back to those decimal points at the end. Whatever you have to do to remind yourself not to forget them, make sure you do it. Now, I'm going to start to multiply by that 5. Remember, we have to work our way right to left when we multiply. And when we do so, and we take care of all of the carries correctly, then what we're going to get in the first line of the answer section is 2010. Okay, no problem there. I've done it a little quickly, but hopefully you already did it as well when you were working on it earlier. Now, I'm going to go to my second line of the answer section, and I'm going to write in a 0 to remind me that we're multiplying now by that 6. And then we begin the multiplication by 6 with the 2 that's in 4.02. Now, once we have completed that line of the answer section, we'll see that the second line is 24120. Now, what about that 0 in 0.65? That's like the third digit I should have to look at there. And if you think about it for a second, we really don't have to do anything with that 0, because 0 times any number is still going to be 0. So basically, if you worked with that 0 and wrote up an answer section for that, you would just end up writing a whole string of zeros in the third line of the answer section. And when you go to add everything up, all of those zeros would be useless. So at this point, I suggest we don't even worry about that 0 in 0.65. So at this point, my answer section really has two rows. I have a 2010 plus 24120. And remember, these two numbers, because they're about to be added, do have to be lined up appropriately. So I have to make sure that those digits have lined up correctly before I add. Anytime you add or subtract, the corresponding digits must be lined up correctly. Now, if I add those two numbers vertically, I'm going to end up with 26130, which looks like my answer is 26,130. But of course, again, as with the previous two examples, that's way too big. So I know that I need to do one last step, if I'm thinking about it, before I finish this problem. To finish the problem, I'm going to go back to those original numbers to see how many digits were to the right of the decimal point. By the way, let me emphasize here, I don't care how many of the digits were to the left of the decimal point at this stage of the problem. I only want to look at how many of the digits were to the right of the decimal point. In this case, it was 4. There were 2 digits in the first number that were to the right of the decimal point, and there were 2 digits in the second number that were to the right of the decimal point. And that means I need to place my decimal point in the final answer in such a way that 4 of the digits are to the right of the decimal point. And in this case, that means the decimal point needs to go between the 2 and the 6. And that means my final answer is going to be 2.6130. Now, let's just make sure we believe that this answer is in the right ballpark before we move on to our next problem. This problem started with 4.02 times 0.65. So it's like we're multiplying the number 4 by a number that's pretty close to 1/2. How much do you get when you multiply 4 by 1/2? Well, it's the same as dividing 4 by 2. And 4 divided by 2 is about 2. Well, it is 2 if you're taking exactly 4 divided by 2. So our answer here should be close to the number 2. Is it? Well, it is. If you go back and look at what we did after we inserted that decimal point, you'll see that the answer was 2.6130. So we can be confident that we have the right answer, or at least that we aren't making a huge error in our calculations. Is that the answer that you got when you did the work? If it is, great job. That was a tough example with all those digits floating around. And if it's not the answer you got, don't worry. Just keep practicing. There will be lots more practice to do in the workbook, lots more problems there to work on as well. And of course, you can find other examples elsewhere in other textbooks if you really need to practice this multiplication with decimal numbers. Now, we've completed a few examples of multiplication which involved decimal numbers. I'd like now to transition to the other major topic in this lesson, which is dividing one decimal number by another. Let's begin with an example where only one of the numbers looks like a decimal number, but the other number is a whole number. Let's do the following. Let's divide 24.57 by the number 7. Now, as with our long division problems, which involved two whole numbers a few lessons ago, we're always going to start these kinds of division problems by drawing a right parenthesis followed by a horizontal line segment in the usual fashion, just like we did for whole numbers. Then I want to place my divisor, that in this case is the 7, on the left-hand side of the parenthesis, and we're going to place the dividend of 24.57 underneath the horizontal line segment. Okay, now there's something that we have to do in these kinds of problems which is very different from what we did with the multiplication problems a few moments ago. Here, where we have division with decimal numbers, we have to take care of the decimal point right now. At this early stage of the problem, I want to push that decimal point or write it in such a way that it never goes away. So here's what we're going to do. We're going to go back to what we've already written, and we're going to write a decimal point in the answer section. That's just above the horizontal line segment. And we're going to write that decimal point in such a way that it lines up exactly above the decimal point that's in the dividend. And so that's going to give me, at this point, my right parenthesis, my horizontal line, my 7 out on the left, 24.57 underneath the line, and just above the line, a decimal point that's right lined up, if you will, vertically with the decimal point in 24.57. Now, it looks a little strange to put that decimal point there now, but that decimal point is not going to move. That's where it needs to stay, and it's going to help us with our alignment of all the other digits once we get started. Now that that's done, we really don't have to do much with that decimal point anymore once you've written it in there. We just need to be careful to place all of our answer digits in the correct location. But bottom line, we can basically now ignore the decimal point that appears in 24.57. Okay, now let's do the division. We've talked enough about the setup of the problem, which of course is very important, but now we need to walk through the division. So let's do it just like we did with whole numbers. How many times does 7 divide 2? Well, 0 times because the 7 is too big and the 2 is too small. So we're going to give ourselves another digit and we're going to ask, how many times does the 7 divide 24? Well, that's 3 because 7 times 3 is 21, while 7 times 4 is 28, and 28 is bigger than 24. So we now write a 3 in the answer section, and it has to be written above the 4 in 24. Remember, that 3 is the number of times that the divisor 7 went into 24, and that's why the 3 has to be written above that 4. I then write a 21 below the 24, and I subtract, and 24 minus 21 is 3. I now drop down the next digit, which is a 5, and now we have 35 down at the bottom of our answer section, or our work section, if you will. It's not really the answer section there. And I want you to notice that I did not drop the decimal point down with that 5. I'm now ignoring that decimal point completely. How many times does 7 go into 35? Well, it goes in exactly 5 times. So I'm going to write a 5 just in the answer section above the 5 that's in that dividend. That was the last digit that was in play as we were working out this step of the problem. We then write a 35 below the 35 that's already there, because 7 times 5 is 35, and we subtract. That gives us 0. It's not a problem. We then drop down our next digit, which is that 7 that's inside 24.57. And that means I now have 7, or what looks like 07, down at the bottom of our work section. But that's okay. It's just 7. How many times does 7 go into 7? Well, it's exactly 1 time. So I'm going to write a 1 in my answer section, just above the 7 that's in 24.57, since that was the last digit in play at that point. I then write a 7 under the 7 in the calculation section, and I subtract to give me 0. I have no other digits to drop down, and so I'm going to stop. And since I have a 0 at the bottom, I know I have no remainder, or 0 remainder if you will, and my final answer is sitting in the answer section at the top of our work. It's 3.51. Now, did you notice that we don't have to goof around at all with the decimal points at the end of this problem? It was already there for us thanks to the earlier work that we did. But does the answer make sense? Well, we were dividing 24.57 by 7. We know that 7 times 3 is 21, and 7 times 4 is 28. And 24.57 is between 21 and 28. So my final answer was supposed to lie between 3 and 4. Well, did it? Of course it did. It was 3.51. And so we know that our answer is in the right ballpark, and we know we're done. Now, let's look at another example, this time where the divisor itself is also a decimal number. It's very important that we see this kind of example. Here's the example. I want us to divide 5.676 by the number 1.2. Okay, we're going to start as usual by drawing up the problem with the 1.2 on the left side of my parenthesis and the 5.676 underneath my horizontal line segment. Now, there's a very important step that must be done here before you do anything else in this example. We now want to move the decimal point in the 1.2 over to the right so that the divisor changes from 1.2 to 12. Why do I want to do that? Well, it's just so much easier to work with a whole number divisor. But if you're going to move that decimal point in 1.2 over 1 digit to the right, then in order to keep everything even, you have to move the decimal point in 5.676 over to the right 1 place as well. That means that we're basically changing our problem to this. Divide 56.76 by 12. And so I'm going to rewrite the problem so that the divisor is now 12 and the dividend is 56.76. You see how both decimal points moved over 1 place to the right so that we would get a divisor, which was a whole number. And yeah, the answer is going to be exactly the same as the answer would have been for the original problem. It's just that I can now work much more confidently knowing that I'm dividing by 12 and not 1.2. So in every one of these decimal division problems, the first thing you want to do is move that decimal point in the divisor over to the right in such a way that the divisor becomes a whole number. Now, once you've cleared that decimal point in the divisor, the next thing you want to do is write in the decimal point in the answer section immediately above the decimal point in 56.76. You want to do this part of the problem at this stage, not before. So first I'm going to move the decimal point out of the 1.2 to give me a 12 on the left and 56.76 on the right. And then I'm going to put that decimal point up in the answer section so that I know it's there. It's sort of like an anchor, and that helps me to line up all the digits of my answer once I have that decimal point written in the answer section. And now, and only now, I can start doing the division work itself. And I can also sort of ignore all those decimal points because they're all locked into place at this point. So, how many times does 12 go into 5? Well, it goes in 0 times because the 5 is smaller than the 12. Give myself another digit. How many times does 12 go into 56? Now I really need those basic facts that I've been talking about, those multiplication facts. And here I need them for the number 12. Well, 12 goes into 56 4 times because 12 times 4 is 48. So I'm going to put a 4 above the 6 in 56. I'm going to put that in the answer section. And I'm going to write 48 below the 56, and then I'm going to subtract. 56 minus 48 is 8. And so I write that in my work section, and then I drop the next digit down. That's a 7. So now I have 87. Now again, I'm ignoring that decimal point. It's not being dropped down with the 7 at that point. I can treat everything as if it was a whole number because I've already put in all the decimal points that need to be put in the problem. Now how many times does 12 go into 87? Well, it's 7 because 12 times 7 is 84. So I'm going to write a 7 above the 7 in 56.76, and I'm going to write an 84 below the 87, and I'm going to subtract. 87 minus 84 is 3. So I write that in my work section, and then I drop down the last digit, which is a 6, and that gives me 36 at the bottom of my work. How many times does 12 go into 36? Well, it's exactly 3 times. So I write a 3 above that last 6 in my answer section, if you will. I'm going to write a 36 down in my work section. 36 minus 36 is 0. There are no more digits to drop down, and I have a 0 remainder. That tells me I'm done. And so my final answer is already sitting in the answer section with the decimal point already placed. It's equal to 4.73. Now, let's quickly look at one last example as we close this lesson. I'd like you to try it first before we work on it together. I want you to divide 6.3 by the decimal number 1.4. Okay, let's start by setting up the problem. Right parenthesis, horizontal line, 1.4 goes out to the left because it's the divisor. 6.3 goes underneath the horizontal line, it's the dividend. What's the first thing to do? The first thing to do is to move those decimal points together to the right, in this case, so that we can get the 1.4 turned into a 14, so that it's a whole number. That means that my problem now looks like 14 is dividing 63. And I want you to notice something. I'm still going to put that decimal point in the 63. So the decimal point now is just to the right of the 3. Now, I realize that we look like we're dealing with 2 whole numbers here, but we still need to put that decimal point in. And I'll show you why in just a moment. So put that decimal point up in the answer section, just above the decimal point that was there in 63. And now let's do the division. Well, obviously, 14 doesn't go into 6. The 6 is too small, and so I'm going to need to ask myself, how many times does 14 go into 63? Well, the answer is 4, because 14 times 4 is 56. So I'm going to write my 4 just above the 3 that's in 63, so it's basically going to be just to the left of the decimal point that I already put in the answer section. And then I'm going to put a 56 under the 63, since 14 times 4 is 56. I subtract, and I get 7. Now, let's wait just a moment. We've got a remainder. So what are we going to do? Well, here's the answer. Because we're working with decimal numbers, I have no problem with us throwing in a few extra zeros to the right of the decimal point in my dividend. I'm allowed to do that because 63 is the same as 63.0000 in the context of this problem. So I'm going to put a few extra zeros to the right of that decimal point in the dividend, and then I'm going to drop down those zeros one at a time as much as I need to try to finish this problem. In fact, I'll give you a hint. We really are only going to need one of those zeros to be put in this case, because I've already worked out the details in my own mind. And so I know that I just need 63.0 as my dividend. It really will be enough. Now, you don't know up front how many zeros you'll usually need. I'm just telling you here that I know that we only need one 0 thrown in to the right of that decimal point. Now, once you've written in that 1 0 in your dividend, you can drop it down next to the 7. Now, what does that give me? Well, it gives me a 70 now at the bottom. How many times does 14 go into 70? Well, if you do a little work on a piece of paper off to the side, you'll see that 14 goes into 70 exactly 5 times. So I'm going to write a 5 above that 0 that was in 63.0. I'm going to put that 5 in my answer section. I'm going to write a 70 below, do my subtraction. 70 minus 70 is 0. And even if you had more zeros to drop down in the original problem, they wouldn't do you any good. You would just keep getting 0 down at the bottom. There's no extra work to do. And so we can stop at this point and read off our final answer. It's basically 4.5. So this is pretty neat because what this says is that 6.3 divided by 1.4 is exactly 4.5. Now you could check that, you know. How would you do it? Well, since division is the opposite of multiplication, you can multiply the 1.4 times the 4.5, and that would get you 6.3. And that would be good practice anyway, given that multiplying 1.4 times 4.5 was the kind of problem we did earlier in the lesson. Checking your answers is always a wise thing to do.